Hey guys, I'm starting lesson 19. This first page I'm going to be showing you is page 103. So this lesson is different than what you've been looking at so far. We are working with line graphs. So line graphs are one way of displaying data. I attached a short YouTube video to your activity on Seesaw, just kind of introducing you to line graphs. I think you guys have seen them before. But line graphs basically show data, and then you can analyze the line plots to kind of see if there's any patterns. So the first line plot we're going to look at, line graph, it's called rainfall accumulation. So the word accumulation just means like the total amount. So this is over one day. It's March 4th, 2013. And if we look here, it says they measured every half hour during a rainstorm. It began at 2 p.m. and ended at 7 p.m. So if you notice down here, this is the time. So the first rainfall recorded was at 2 o'clock. It's actually at 0. The rain didn't fall until then. And then it goes all the way till 7 o'clock. And then over here, so the x-axis is time. The y-axis is the rainfall that's measured in inches. So I first want to kind of talk about how they've scaled this. It's not a regular coordinate plane because the scales don't match, right? So this is time, this is rainfall. So those are two different units. But that's okay. We can still look at them and kind of analyze what they're showing us. So if you notice, they've already told us it's measured, the rain is measured every half hour. So anytime you see one of these points, it's at a half hour time. So start at 2 o'clock, right here would be 2:30, 3 o'clock, 3:30, 4 o'clock, 4:30, so on, okay? That means if this is 1/2, this is 1/4 of an hour, right? And this is 3/4 of an hour. So if you were to split an hour into fourths, each fourth would be 15 minutes, right? So this would be 2:15, 2:30, 2:45, 3 o'clock, 3:15, 3:30, 3:45, 4 o'clock. Okay, so on the time, that's how it's divided up. When we look at rainfall, it's also divided up into 4 sections, but it's 1 inch, right? So this would be 1/4 of an inch, 1/2 of an inch, 3/4 of an inch, 1 inch, 1 1/4, 1 1/2, 1 3/4, 2 inches. So that's really important to kind of look at before you ever start analyzing a line graph. Okay, so we're going to be using this graph to answer some questions that they are asking us down here. So I'm going to have to kind of scroll up and down to look at the graph every now and then. Okay, the first question says, how many inches of rain fell during this 5-hour period? Well, the whole time is from 2 to 7, right? And they're talking about the accumulation of rain, which means in the first 30 minutes, it rained this amount, which is 1/4 of an inch, and then they kept adding to that amount. So it's not like at 2 o'clock it rained 0 inches, at 3 o'clock it rained 3/4 of an inch. They are adding it as they go. That's what it means to accumulate. It's like if I had a glass of water and I kept adding water to it, that is accumulating. I didn't dump out the water in between. I hope that makes sense. So we're trying to find out the total accumulation of the rain, which means I'm looking for the last time here. It's 5 hours, a 5-hour period of time, which ends at 7 o'clock. So I'm looking for this amount right here. So if I go up from 7, I look to see where this point is. I can drag across, and I notice it's just above the 2 inches. So this would be 2 1/4 inches. So in a 5-hour period of time, 2 1/4 inches fell. 2 1/4 inches of rain fell. Next, they ask us, during which half-hour period did 1/2 inch of rain fall? Okay, so I need to find where 1/2 inch of rain fell. However, that doesn't mean that the data point is going to be along this 1/2 inch or 1/2 inch. It just means that the difference between one point to the next point is 1/2 inch. Okay, so I'm looking for between 2 points where 1/2 inch of rain fell. Okay, remember this is a half-hour period of time, half hour, half hour, half hour. So every point is showing 1/2 hour period of time. Okay, if I move from 2 to 2:30, I'm noticing that that's only 1/4 of an inch, so that's not half. Now I'm moving from 2:30 to 3. I see it started at 1/4 and it's ending at 3/4. So that is the 1/2 inch of rainfall, right? Because the difference between 1/4 and 3/4 is 1/2 inch. Or you could think of like if you move up 2 units, 2 boxes, 1 box, 2 box, or even just like count, this goes here, 1, 2, that equals 1/2 inch of rainfall. So between 2:30 and 3 o'clock, 1/2 inch of rainfall. Then I'm going to explain how do I know that. The line went up 1/2 inch between that time. Or I guess 1/2 inch as the time, and from 2:30 to, and make this font a little smaller, I think, if I want to fit it. Okay, there is that one. Next it says, during which half-hour period did rain fall most rapidly? How do you know? Okay, so this is something, the more you use a line graph, the more you know what the data means. So if this is rainfall, I am looking for a half-hour period of time. So between two of these data points, sorry, I can't think of the word. I'm looking for the period of time that had the most rainfall. So, all right, how do I find that? Well, remember the rain is accumulating. And as rain, you can even visualize it this way. As rain accumulates more, like if, again, I go back to that, I was talking about filling up a cup of water. The water is going to rise faster when more rain is added, right? Or more water is added. You can kind of think of that with this graph. I'm noticing right here, that's a very steep incline, which means it rained a lot during this period of time. No, this one looks like it could maybe be almost, but it's not quite. This one goes up by 1, 2, 3 boxes. This one goes up by 1, 2 boxes. So between this time and this time is where the rain fell most rapidly. And I know that because it is the steepest. So this time is 4:30. This time is 5 o'clock. All right. It says, what do you think, or why do you think the line is horizontal between 3:30 and 4:30 p.m.? So let's look at 3:30 and 4:30 p.m. 3:30 and 4:30. So this is just a straight across line. It is not increasing at all. So on the graph, that just means between 3:30 and 4:30, there's no rain, right? If I look at 3:30, it's at 1 inch. If I look at 4:30, it's still at 1 inch. So if it stayed at 1 inch, that means no rain fell. The last one's a little tricky. So, and you actually don't really even need to look at the graph to answer this. It says for every inch of rain that fell here, a nearby community in the mountains received 1.5 feet of snow. Okay, so here, 1 inch on this graph. Does it say where we're at? No. 1 inch on our graph, 1 inch of rain equals 1.5 feet of snow. So 1.5 feet of snow. That's basically what they're saying. So this is our graph, and they're saying in a nearby community, they get this amount of snow for every 1 inch of rain. Okay, then it says how many inches of snow fell in the mountain community between 5 p.m. and 7 p.m. So we actually do need the graph. I need to figure out first how much snow or how much rain fell between 5 p.m. and 7 p.m. So let's go here. 5 p.m. was at 1 3/4. 7 p.m. is, what is it? 2 1/4. Okay, so let's figure out how we can do this. First, you have to figure out, all right, what is that total amount of rainfall between 5 and 7? I just told you 5 o'clock is 1 3/4. 7 o'clock is 2 1/4. So that total amount of rainfall is 1/2 inch, right? So let's start with that. A total of 1/2 inch of rain fell between 5 o'clock and 7 o'clock. All right, so now we're trying to figure out what that means for the mountain community. That means the mountain, I'm going to put this down here. In the problem, they told us for every inch of rain, the mountain community gets 1.5 feet. So we are saying it's 1/2 inch of rain. So the mountain community will get 1/2 of 1.5 feet, right? I'm going to repeat that. So 1 inch of rain here, remember I wrote it down here. 1 inch of rain on our graph is 1.5 feet of snow for the mountain community. But the amount we're using on our graph is 1/2 of an inch, which means I have to take 1/2 of this because this was from 1 inch of rain on our graph. So basically what they got is 1/2 of 1.5 feet. So they got 1/2 of 1.5 feet of snow. That sounds confusing, but you guys know how to solve this because you're basically just doing multiplying or dividing fractions here. So how could we figure this out? Well, I could take 1/2 of 1.5 feet and by converting it into inches. Okay, so I know I'm starting off with 1/2. Now I need to think of 1.5 feet of snow. How many inches is that? Well, 1 foot is 12 inches. 1/2 of a foot is 6 inches. So that total would be 18 inches, right? So you can find 1/2 of 18 inches, which is 9 inches. Or you don't have to convert it to inches. We can just take 1/2 of 1.5 feet. Okay, I should probably move this down a little bit so you guys can see that more clearly. All right, when I multiply two fractions like this, remember I need to make this into an improper fraction. So I'm actually doing 1/2 times this as an improper fraction is 3/2. So 1/2 times 3/2. You can do that on your own. Maybe you could do it in your head, but it is 3/4 of a foot. So that would require some work. So to answer the question, the mountain community would get 9 inches or 3/4 foot of snow. Okay, again, this one's a little tricky. You just have to really think of what the question is asking you. It was more about doing the math here than it was using the graph. All right, I'm going to make another video for the next page, which is page 104.